Okay. So let's get into what we're going to do today, which shouldn't be too crazy. All right. So, yes. The warm-ups. Yes. Abby, would you mind going around and getting those for me? Thank you. Okay. Thanks for saying something, Andrew. So, today and Monday, we will be talking about something called verifying trig identities. We're going to introduce the idea today, and then Monday we'll get some more practice with it. And then Tuesday we are scheduled for a quiz. Verifying trig. This very thing that we're learning about today for the first time, and then Monday. Okay, now, the quiz on Tuesday, okay, if you look at your little study guide sheet here, okay, is actually a partners quiz. So, you will be allowed to work together. Now, by partners, I know partners normally means 2 people, but I will allow up to 3 people to be in a group if you want. Okay? But Mr. Witt, we have a group of 4. Break it into 2 groups of 2. Alright? I just did the math for you there. Okay? Just like those population projects, right? We can break them up. So I will allow you to do groups of 1 if you want to be a lone wolf. That's your prerogative. 2, okay? And then 3, but no more. No more than that. Okay? And that will be on Tuesday. That will be on Tuesday. All right, so that's just there to help you out some. Okay, so to jump into this, kind of I introduced this idea, right? We already have some trig identities that we know. So, for example, what is a trig identity? You know, for example, we know that sine of x is equal to 1 over what other trig function? Cosecant. Right, I'm sure you all were thinking it right up in your brains right there, you know. You weren't panicking and thinking, oh my gosh, don't call on me, Mr. Wood. All right, cosine of x. Now everyone knows, right? What's this one going to be? 1 over secant. Yeah, okay. Got another answer there. Thank you. Okay, so yes, cosine is 1 over secant. And then let's go ahead and do tangent as well. Tangent is 1 over cotangent. Oh, very good. Okay, and then of course we can change all those up. So then I can also say, okay, that means cosecant then is just 1 over the sine of x. You know, similar kind of relationship there. Secant of x is 1 over cosine of x, and cotangent of x is equal to 1 over the tangent of x. Okay, and these are collectively known as the, wait for it, reciprocal identities. Okay, these quantities are equivalent, right, or they're just reciprocals of each other. All right, and we also have 2 other identities for tangent alone and cotangent, right? If we remember that tangent of x is equal to a ratio of what 2 trig functions? What over what? Sine over cosine. Sine over cosine. Okay? And therefore, since cotangent is the reciprocal of tangent, what will its ratio be? What over what? Cosine over sine. Yeah, exactly right. Okay? And again, not that you asked for it, but I'm going to say it anyway. You know, one way to help remember there, right, is that cotangent of x is equal to cosine over sine, whereas tangent is sine over cosine. Okay? So cotangent is the exact same quantity as cosine divided by sine. Tangent is the exact same. Tangent of x is equal to the exact same thing as sine of x over cosine of that x. All right. Okay. So then we have some other identities here, and I'll just kind of introduce it here. And these are called the Pythagorean identities. Okay, these are also named. Okay. All right. The main Pythagorean identity is sine squared of, I'm going to use now theta. It doesn't really matter whether you use x or theta because they're just variables, right? So I'm going to say sine squared of theta plus cosine squared of theta is equal to 1. Okay. Sine squared of theta plus cosine squared of theta is equal to 1. Okay. Sine squared of theta plus cosine squared of theta equals 1. And then there are 2 other Pythagorean identities, but they all derive from this. Okay? They all derive from this. So if you can, there's two other ones, but if you can remember this one, you can derive the other ones. You can come up with the other ones on your own without actually having to memorize them. Okay, if you want to memorize the other ones, that's fine. But there's this one. Okay, the other Pythagorean identities are found by taking this and dividing both sides by sine squared or dividing both sides by cosine squared. Okay, so for example, if I divide both sides by sine squared, so again, this is the first one. Okay, if I take that sine squared theta plus cosine squared theta, and it's equal to 1. If I divide through by sine squared, and again, in an equation, when you divide both sides by sine squared, everything on both sides gets divided by that sine squared. Okay, we can't just like pick and choose where we divide. It's got to be the left-hand side divided by sine squared, the right-hand side divided by sine squared. And I just broke up the sine squared there to make it easier. Okay. What is sine squared divided by sine squared going to be? It's not a trick question yet. 1 plus, okay. What would cosine over sine, what would cosine squared over sine squared simplify to be? Cotangent squared, yeah, cotangent squared. And then what's 1 over sine squared going to be? Cosecant squared. Okay, and so there's another Pythagorean identity. 1 plus cotangent squared equals cosecant squared. Okay. And so there's one more then, and it's when we divide both sides not by sine squared, if we divide both sides by cosine squared. Okay, so again, I'll start with sine squared theta plus cosine squared theta equals 1. And we'll divide through by cosine squared of theta. Okay, and so yes, sine squared divided by cosine squared simplifies to be what? Tangent squared. Okay, cosine squared divided by cosine squared? Is that 1? 1. And then 1 over cosine squared. Secant. Secant. Okay. Secant squared. That's right. Okay. And so that's the third Pythagorean identity there. Okay. And again, I'll show you how we're going to use those in just a second. Okay. But before I show you how we're going to use them, I'm going to show you where this Pythagorean identity comes from. Okay. You will not need to, remember this, but at least, just follow along with it and see, see what you can see here. Okay. So the origin of this, where does this come from? Well, it comes from the idea of Pythagorean, right? So we're actually it's going to use an application of the Pythagorean theorem here. So if I set up a right triangle, and again, just follow along. You don't need to write this part down if you don't want to. Okay. Okay. I'm going to put an angle theta in for one of the acute angles there, and I'll label my sides A, B, and C, right? Kind of like the traditional way that we do that. A and B are like normally the legs. C is normally the hypotenuse there. Okay. And so we know, right, that these three sides are related by the Pythagorean theorem, right? A squared plus B squared equals C squared. Right? That's always true for that right triangle there. Okay. Simultaneously to that, though, we also have these trig ratios that relate pieces of this same right triangle. So, for example, sine of theta would be what ratio? What over what here in this particular right triangle? What would the sine of theta be? A over C, right? Opposite A over hypotenuse C. What would the cosine of theta be? The same theta. What would cosine of theta be? What's that? Yeah, B over C. Adjacent to the theta there. Adjacent, so B over C. Adjacent leg, B over C. Okay? Now, with these two trig ratios, right, we see, bless you, we see some of these variables showing up that are also in our Pythagorean theorem. In fact, if I just manipulate things here a little bit, I'm going to multiply this C, that's dividing the A, I'm going to multiply both sides by C here. We end up with C times the sine of theta equals A. Right, just multiply both sides by C. Same idea here, I get C times the cosine of theta equals B, right? Again, just multiplying both sides by the C there. Well, this A here and this B here are the exact same A and B as the ones right here in Pythagorean theorem. So we can substitute, right? C times the sine of theta, quantity squared, plus C times the cosine of theta, quantity squared, equals C squared. Now, since I'm squaring this product, right, we can distribute that square. So I could rewrite that as c squared times the sine squared of theta plus, and the same deal here. Both the c and the cosine are being squared here. It's a product, so we can distribute this square. C squared cosine squared theta equals c squared. Okay. And then there's a GCF here of what? C squared, which we can factor out. And we'll have with sine squared theta plus cosine squared theta equals c squared. And we can divide both sides by c squared, and we get our identity. Okay? And so there's the origin of that Pythagorean identity. Okay? It's just a combination, a marriage of our understanding of both sine, cosine, tangent, and the Pythagorean theorem. Okay? Using all the right triangle stuff. All right? So we're going to be utilizing these identities to, I'm going to use this word, and some of you are going to cringe, but to kind of like prove that or to verify or prove that an equation is true. Okay? So, but it's not the same proving that you guys are used to in geometry. It will be a little challenging in some cases, yes, but it'll get easier as you practice. Okay, as you develop kind of understand what we're supposed to do. So let me show you what I mean by this. Okay, so what we're going to be using these identities for today and Monday, and they have lots of applications other places, but today we're going to be just trying to verify the following equation. Okay, so here's what we're trying to verify. We're trying to verify that the secant of theta times the sine of theta over the tangent of theta is equal to 1. Okay. Now, we're trying to verify that the left-hand side and the right-hand side are equal here. All right. So a better way probably to write this is to maybe put like a question mark, because we don't really have the fact that these two things are equal. I mean, we do have it, right? That's what we're trying to show. We're trying to show the left-hand side is equal to the right-hand side here. But because we're not exactly sure the left-hand side and the right-hand side are equal, we can't like use those algebra properties where we like do the same thing to both sides. Okay? So there should not be, in these verifying problems, there should not be any point where you're like multiplying the same thing to both sides, dividing the same thing to both sides, adding or subtracting the same thing to both sides. We can't really use that because that's kind of like putting the cart before the horse. We haven't shown that these two things are equal. We're told they're equal, but we're supposed to verify that they're equal. So we don't have that to then use the same thing to both sides. So then how are you supposed to do this? How are you supposed to do this, right, when we can't use algebra, right? We can't add the same thing to both sides, multiply the same thing to both sides. The idea is to, okay, focus on manipulating one side to match the other side. Okay? You can choose any side that you want. However, in this particular problem, it's going to be much more difficult to try and manipulate one to match secant of theta times sine theta over tangent theta. It'll be much easier to take that secant times sine over tangent and simplify that to try and get 1. So typically, you will work with the left-hand side. Okay, and that's going to be my suggestion to you as well. These problems are written in such a way, these problems are written in such a way that it's the left-hand side that you want to simplify to then, or to rewrite in order to match the right-hand side. So the left-hand side is kind of like what we have to work with. The right-hand side is our goal. Okay, typically, it's better to think of it that way. It can get very confusing if you try and start manipulating the left-hand side and the right-hand side simultaneously, or if you try and work with the right-hand side, especially in a case like this, because it's like one you can take the directions. All right. Another idea too, another little helpful hint, is to change everything to be in terms of sine and cosine. Okay, that's a tip. That doesn't always help, but it's a pretty good general guideline to follow there. Okay, and then use identities / simplify to match the right-hand side. Okay, and always try and keep that right-hand side in mind as you're simplifying. Right? You can see here that we have a product of things on the left-hand side. On the right-hand side, we have a single quantity. So that means we probably want to try and multiply these things together somehow in order to then get that single quantity of 1. Right? We have a product, bless you, of things here. Here we just have a single thing, so we probably want to try and get those things all together. All right? So let's rewrite things. Secant of theta, we can rewrite as what in terms of sine or cosine? 1 over cosine, right? So bless you. So secant of theta, we'll just rewrite that as 1 over cosine of theta. Times then, sine of theta, well that's already written as sine and cosine. And what about tangent? How can we rewrite tangent in terms of sine and cosine? Sine theta over cosine theta. Okay, and again, we're trying to show that that equals 1. You can keep bringing down the 1 if you want to, or you can just leave the equal sign and it'll be understood that you're trying to equal 1 there. Okay. Okay. Ideas from here. Yeah, Nick?
You multiply sine theta by cosine theta over sine theta.
Right. So instead of taking that sine theta and dividing by this fraction, we can instead of dividing, we can multiply by the reciprocal of this fraction. So now we have 1 over cosine theta times sine theta times cosine theta over the sine of theta. Okay. And now how can we simplify from here? Can anything cancel out? Yeah, Andrew?
The sine thetas will cancel out.
Yeah, it's sine theta over 1 technically here, so that sine theta is in the numerator, this sine theta is in the denominator, so gone and gone.
And then you're going to be left with cosine theta over cosine theta, which is going to be 1.
Right, and so we're left with 1 times 1 times 1 over 1 times 1 times 1, which is just 1 equals 1. Check. We verified that secant of theta times sine theta over tangent theta is exactly just equal to 1. Okay? All right, and that's kind of like the proof there. We've shown they're equal. We've shown they're equal. We want to show that this is equal. So there we go. Okay, so if you have questions on any of that? All right, let's try another one then. Yes. Say again? Yes. I know, right? No. No. I don't think it's a lot, but, you know. Who knows with my opinion, right? Who knows what's up in my head right now? Who knows? Who knows? All right. So other things you might be asked to do, you might also just be asked to simplify. Okay? So it can verify, right? Verify, that's when we have an equation. We can also just be asked to simplify. For example, you know, you could have like cosine squared of x times secant squared of x minus 1. Okay, we could just be asked to simplify here. Okay. And again, there's different avenues to take here. There's different pathways to take. Any ideas about how we could maybe go about trying to simplify this thing? Yeah, Alyssa?
You can do 1 over cosine.
So change what to 1 over cosine?
Secant.
Change secant squared to 1 over cosine squared. Okay. Okay. And then what could we do? How is that helpful? What could we do from this point?
Could we distribute?
Distribute. Aha, yes. Because we do have something in front of parentheses there. Very good. So cosine squared times 1 over cosine squared will be just what?
1.
Just 1, right? Because it'd be cosine squared over cosine squared, so it's going to be 1. Minus, and then 1 times cosine squared is cosine squared of x. Okay? Can we simplify any more?
Squares.
So what?
Difference in squares.
Okay, to different squares, we could like factor it if we wanted to. Yep, so we could go this way. Uh-huh. And again, this is where that word simplify, right, which doesn't really have like an official mathematical meaning. You have to kind of like think in your mind, is this more simple or is this more simple? You know, I don't know. You know, sometimes we do want to factor things. Sometimes we don't want to factor things, right? So that like is kind of a nebulous, you know, like, well, where are we supposed to stop? So, you know, either one of those is fine. However, I will say there is something we can do back up here with this 1 minus cosine squared of x. This is equal to sine squared of x. How is 1 minus cosine squared equal to sine squared of x? One of the Pythagorean identities that we talked about. That's right. Okay, if we go back to the original one that I wrote, sine squared plus cosine squared equals 1. If I subtract over a cosine squared, right, if I subtract cosine squared on both sides, this is an identity, so it's equal. I can, you know, manipulate like just like using algebra. 1 minus cosine squared will be sine squared. 1 minus cosine squared will be sine squared. Okay? So it's kind of up to you there, but I think sine squared is probably the best way to go there, obviously, because it is the most simple. Okay, but that's the idea. Questions on any of that? Okay. There's also an alternative. With that understood, then we could have gone from here, secant squared x minus 1. Let's see if I can find that here. Okay. Secant squared is equal to tangent squared plus 1. If I subtract 1 from both sides, I'll have secant squared minus 1 equals tangent squared. So I could have here kept the cosine squared and made that tangent squared. Right? Again, tangent squared plus 1 is secant squared. So I subtract 1 from both sides, it'd be secant squared minus 1 equals tangent squared. Secant squared minus 1 is tangent squared. So we could have gone this way too. So this is another like I don't know, character trait, I guess, of these kind of problems is that you do have multiple paths, or sometimes there's multiple paths you can take. How can we simplify from this point, though? What can we do here to continue to simplify this? Evan? Tangent is sine squared over cosine squared. And then what can we do with the cosines? They cancel. It's cosine squared over 1, so cosine and cosine, boop, boop, and it's just sine squared. We got the same thing. What? We better have gotten the same thing, right? We better have. Okay, so these simplifying ones, they're like the verifying, except you're not given a target. You're just supposed to kind of simplify. And the verify, it's like, here it is, simplify this to make it 1, right? So you're given a target. Here, you're not given a target, you're supposed to kind of just do what you can. Okay. So I don't know. I don't know if that makes it easier or harder. Maybe both. I don't know. So, question? Yes. So, let me give you guys one to try here. Secant squared x times 1 minus the sine squared of x equals 1. And this is for a verify, okay? Because I have work for you to simplify, and I want you to show me that it equals 1. Okay? So show me that that is equal to 1. Okay, you can use your identities and stuff. Okay. You need a grade sheet, Abby. And the numbers might be all over the place because we're in and out for AP tests and stuff like that. So, but there should be 5. Again, you kind of follow the guidelines that I gave you earlier, where you change everything in terms of sine and cosine if you want.
the one that's disputed. No, distribute. Doesn't it become minus distributed? What's one over cosine times one? It's just a one. Is one over cosine minus tangent? One over cosine minus tangent? Well, that's one over cosine.
Question. Great. What do you give it this?
Did you verify?
Well, I mean, you could rewrite that if you wanted to. For example, when I see
So one
1
minus
minus
sine
sine squared,
squared x
that looks
equals 1.
kind of like one of those Pythagorean identities, right?
Cosine
Universe
squared.
sine squared plus cosine squared equals 1. What's up, David? Yes. So it kind of looks like that, right?
This is more like
So
geometry where
we don't quite have that, right? The Pythagorean identity is cosine squared x plus sine.
I like the
I
word
like
x more
I
than
like
sine.
first.
Yeah.
We need
I
1
don't
minus
like the way
sine.
I did.
If we manipulate this, I can subtract the sine squared over,
It's so much easier.
right?
So really
So I
like
would
the
have
long
1
and
cosine
complicated
squared
version?
x equals 1 minus sine
The square of x.
So what is 1 minus sine
less
squared?
actual
Same thing as
math.
cosine
Yeah,
squared.
it was more just logic.
So then we put it in there, right?
So what's the deal? Am I gonna take the benchmark today?
Yeah, I'm gonna probably try and make it, well, at least have you start on it. It's supposed to be 70 minutes, but you'll have 60 minutes to do it. So if you'll need more time, I'll get you more time. But you might be able to get it done too. I mean, I have to say, you're pretty quick. So yeah.
And then you can
Alright, I'll see you 4th block.
Yes.
we'll multiply that as cosine
Okay.
squared x over cosine squared x.
So, what can we do here? Yeah, Brian?
You change secant squared,
Mm-hmm.
secant squared to 1 over cosine.
Okay, this is one way to go here. 1 over cosine squared, and then 1 minus sine squared x equals 1. Okay, and so then what did you do?
Distributed.
Distribute it. So 1 over cosine times 1 is 1 over cosine squared still. Sine squared times 1 over cosine squared, what'd you make that?
Tangent.
Tangent squared, right, because they're both squared. So tangent squared. Okay, and then what'd you do from here?
That's where I ended. I
Okay.
didn't do anything.
What's 1 over cosine squared the same as?
Secant squared.
So we're maybe going backwards here a little bit, but it is secant squared.
Okay.
Okay. Now, we see here that secant squared and tangent squared are being related, which we go back to our Pythagorean identities. We have a Pythagorean identity that relates tangent squared and secant squared, right? Now, we don't quite have this situation. We have secant squared minus tangent squared. But how could I manipulate this identity to get secant squared minus tangent squared? What would I do to both sides?
Add tangent.
Well, not add, we would subtract it, right? We would have to subtract the tangent to both sides. And so if I did that, it would be secant squared minus tangent squared equals what? 1. So this is just, we can say 1 equals 1. Check. Okay? Do you see what I'm saying there? Okay? So that's one way to do it. Okay? That's one way to do it there. All right? Anyone do it a different way?
I just have a question.
Oh, question.
When it says verified, does that mean that it does equal 1?
Yes.
Okay.
Like that should be your goal. The right side's kind of your goal. The left side is normally the work that you do. Sometimes, very rarely, you could always work the right-hand side, but obviously taking 1, it's like, what am I supposed to do with 1 to then make it look like this? So it's much easier to take this simplified. So yes, the verifies will always work. It's just a matter of getting to that point.
Okay.
All right, sorry, Emma, different way?
Wouldn't 1 minus sine squared is that
Yes. So using another Pythagorean identity here, 1 minus sine squared is if we subtract sine squared from both sides, we have cosine squared here. So we could say then that's secant squared x times cosine squared x. Again, we make sure that's equal to 1. And then we can go and use Brian's idea that he said earlier. Secant squared is 1 over cosine squared times cosine squared. And they cancel. And so you're left with 1 equals 1. Check. It works. Okay? So that's the idea. Questions on any of that? All right. So I highly, highly, highly recommend, that you guys get started here on this assignment I'm going to give you. I know I didn't give you a whole lot of time, but you're going to want to get started because this stuff, this is not one of these problems you want to wait till Sunday night to start working on it. Okay? So you definitely want to get started right now because these can be a little tricky. Okay. What's the matter, Grace? Is it too few? I know, I should have given you some more. I'm sorry. Are you disappointed, Grace, I didn't give you more than that? I'll try to do better on Monday.
This would my question. When you're doing these, are you also allowed to like use both sides of the equation?
You can, but you can, yes. Yeah. It can cause problems sometimes, I'll say, because if you start working on both sides, then sometimes you'll it's like untangling dots. And you can start to complicate one side more, so that you're going in the opposite direction from one another, rather than taking one and moving it, trying to get as close as possible. But you can absolutely do that, right? But you just can't move things from one side to the other because we don't have the equal. You can't use that same thing. Okay, so again, guys, really get started. Yes. I would think so, yes. I mean, all this